Can you put on a slideshow, please?
I hope slides are visible now.
We can, yeah, it's visible to me. Thank you, dear. It's visible to me. I hope it's visible to all. So continuing from here, so we can we go to the next slide, please? We'll go through these slides. Yeah. So a brief on this introduction is that we established in 1978 during the energy crisis. After the OPEC was formed, so oil was kind of monopolized by OPEC, and then they bullied countries like India, and that was a reason that ENCON came into being, and we said instead of producing oil, let's start saving oil. So PCAG, that's Petroleum Conservation Action Group, was formed by Ministry of Oil, and then they used to send people to the industry to see how the oil can be saved. So that started ENCON, and that's how the name Energy Conservation was coined. ENCON was coined. And so today we are very well known for designing, manufacturing, supplying, and commissioning on turnkey basis of energy efficient systems, predominantly we give turnkey solutions for brownfield as well as greenfield requirements of the clients. And much of the innovations, as I mentioned earlier, were because of the clients' some issues or needs. So year 2022, we won the highest award that was conferred by the President of India. That's the slide what is showing, me and my son over there. So we 22 for the same project that we are going to talk. Please, ma'am, next, please. So currently we are serving steel plants in a big way. So almost all the big steel plants in the country and West Asia onwards till Southeast Asia. Today, mother machinery in SMS sections and somewhere in other forming sections also are again done by ENCON. So getting these technologies or getting this equipments accepted in itself is a big challenge, because in MECON we found that when we gave to RSP, I'm giving you a bit of history also, going little sidetracks. That will be good for the industry, because we should know how to fight the system. So if you fight the system, you can win the system. Otherwise, you don't win the system. So MECON had a separate list of preferred make for Indian suppliers and for foreign suppliers, and their evaluating styles were also different. So that's why most of the time the Make in India story was not very successful for the starting, once Make in India was started some 10 years back. So people were not accepting it, and till the time we had a good interaction with the highest level, means chairman, managing director of MECON was very receptive to all these things, and we got all Indian developed technologies accepted there, and that's how we are in all the steel plants, foundries. Then we are in transformers and distribution industry, like all the big ovens as high as 9 meters tall, with 6 meters depth and 6 meter width. We established uniformity of plus minus 3 degrees, which was in itself a big thing. And when I went to Winsboro in GE, that General Electric, they were surprised that they were not agreeing, till the time a man from GE, Hasur, went into Winsboro. They confirmed that this is what ENCON has done for us in their 26 huge ovens, whereas they were clocking around 10% minus degree centigrade. And in 2000 also we won the CII award for automotive industry, like Tata Motors in Pune. We eliminated almost 3 boilers and converted into radiating applications for their phosphating tanks, for all the liquidating tanks. So was in all aluminum industries. This regenerative burners can do big job. pharmaceutical industries. So all the ovens of Baba Ramdev, this Patanjali, for around, so initial 24, 25 ovens, me and Ramdev, we were working together for the national cause. Then cement industries, the ACC was there, but now ACC is not there. Then we worked the glass industry. When the Taj trapezium was under threat, so Encon developed all the initial burners for various applications, from this glass bangle making to the glass making, means really the literally tumblers what you are using, and the chandeliers and other places where you use glass. And in ceramic industries, we were talking to Tatas for their brick kilns and refractory industry. Can you go to the next slide, please?
Yeah.
So I think we'll skip. I've spoken about this, no, but if you want our R&D activities, we have a dedicated R&D facility where we have developed all these coke oven burners for the country. Earlier, these burners were imported by the steel plants, all the major steel plants from either German was a major supplier to them, and Italians were also there, but we dented their monopoly. So, and then we developed the burners, main burners, then the pilot burners on coke oven, and then on mixed gases, lean gases, and today we are doing gases up to any level, means even BF also we are using. We can enrich them with oxy fuel or oxygen. We can oxy enriched burners we are doing, or 100% pure combustion, oxygen combustion burners we are doing. So then lately we developed regenerative burners, self-recuperative burners, and hydrogen combustion is already on the horizon. So we have already tried it for almost last 1 year. We are trying all this, but this is all the ongoing things what we are doing. So we take R&D activities, and now we are talking of kind of removing induction heating from this continuous heating processes like slab heating furnaces or slab, for rolling mills, for especially for patra industry, what you call strip mills. So strip mills, we are doing all this now. Can you go to the next, please? Next, please, Bhavna. So let's go to the next. We have discussed this. Let's go to BHEL straight, please. Or you're going other way around. Yeah. Let's go. Yeah. So let's go to there should be a video on this. Let's go to the next, please. Let me show you a video on what a regenerative is. Or if you all know what a regenerative is, then I need not show anything to you. So then I'll go to straight away BHEL. So shall we?
We need to see this.
You need to see this. Okay, fine. So can you go a slide down? There is a video on that. One or two more slides down. Yeah, this one. If you click this, yeah.
Burner and regenerator with ceramic media balls. Regenerative burners operate in pairs. In a typical cycle, first, burner A will fire and burner B will act as a regenerator, and then burner B acts as a regenerator by absorbing heat from the exhaust, which gets stored in the ceramic balls. The stored heat gets transferred to air when burner B starts firing. The furnace was tested with multiple cycle times ranging from 60 to 180 seconds, keeping the furnace temperature at 900 degrees Celsius. Energy recovery of 86% was achieved through exhaust gases, which resulted in reduction in fuel consumption. Regenerative burners can recover up to 80% of heat from the exhaust gases and use it to heat up the incoming combustion air, maintain a superior temperature profile in the furnace, and reduce the fuel consumption. Regenerative burners operate in pairs and work on the principle of short-term heat storage in the regenerator, which is attached to each burner, thus eliminating the need of conventional recup. regenerative burner consists of burner.
Okay. So if you go to the slide now, the earlier slides, then I can explain you in slides also. Previous, yeah. So here you see, this is always the system comes in. Yeah, one more previous, please. Correct. So here you see burner A is firing. The whole system comes in a pair always. In any given furnace, you will have a pair working for it. So if a small furnace, you can have a set of one pair, or if you have a bigger furnace, we can have multiple burners. Like in BHEL, the maximum what we have done is 10 pairs we have given for 120 tons furnace. So we have done furnaces from 30 tons to 120 tons, and all their work in pairs. So here what you see is when burner A is firing, all the combustion air, the fuel, everything goes through burner A, and all the flue gases, they exhaust through burner B, and the medium lying there, that's the ceramic balls in burner B, which is slightly yellowish, gets preheated with the atmospheric temperature of the utility. If utility is at 1200 degrees centigrade, so the balls get heated almost at the same temperature. So, and can you go to the next slide? After a time cycle of time T1, which varies from 30 seconds, which we can plan to minutes. So time cycle, so the burners switched off, both the burners, and then after a gap of maybe a few seconds, go to the next slide, the burner B starts firing. You will see that in next slide. Yeah. Now the burner B starts firing, and the combustion air, which was going through burner A, is now going through the medium of burner B. Now, burner B medium, as I said, had earlier mentioned, it was lying at 1200 degrees centigrade. It recovers around 1000 degrees from here and gives it back to the furnace as a preheated combustion air. Thing to note here is, in recuperators, we can go up to 300, 400, 500 also, high performance recuperators. But for high performance recuperators, if you go anything beyond 400, since steel becomes plastic, you have to go for stainless steel. And then you have to go for lagging also. The resultant factor is much, much lesser. Whereas in regenerator, you have not to do any of such things. Here it's ceramic balls straight away preheating the combustion air, going straight into the burner. So everything is direct. You don't have anything going indirectly or traveling through the pipe, or you have to manage pipe losses, or you have to take care of expansion because of the heat. The pipe size has to be much higher for recuperators. So here, all those issues, all those areas are addressed, and then your flame temperature also go higher, and then this burner B starts firing, and then you keep on switching off from A to B, A to B, A to B. After it, so this time cycle can be established looking into what critical uniformity is what you want in BHEL, or sorry, in your reheating furnace or heating furnaces. So in BHEL, we had attained up to, because that was the requirement, plus minus 15 degrees at 1250 degrees C. So at 1250 degrees C, we got this much. But nevertheless, we can always go less than 5 degrees also. We carried out some experiments where we have gone to the uniformity of 5 degrees. That's why I'm saying.
Electrical phone phone
That's why I'm mentioning is because all the furnaces required today by the industry, whether it's for defense.
DSK electrician
See, somebody is talking and we are not able to hear. Yep, sir. Please, sorry, sir. Please go on.
So to this august audience, what I want to tell you that now the current need, what is coming to companies like us, is for furnaces with plus minus 2 degrees uniformity at 1200 degrees centigrade or above. because now the country is going towards manufacturing of defense equipments, the marine equipments, and the nuclear is coming again back. Such kind of furnaces will demand such kinds of performance parameters. So now coming to the performance before, and let me show you next slide. Is anybody having any question, please? Or because we are having a lot of noises from the back.
Yeah, you may have questions, so you can put your question.
Let's go to the next one, please, Bhavna.
Yeah.
Next, please. Okay, this is now what happened in BHEL. If you see serial number 1, the furnace capacity, it was 30 metric tons. It was a 6-meter long furnace. We gave 3 pairs of 1500 kilowatts each. Status, the furnace was handed over in 15th October 1922. Average, when I say handed over, means after 2 years, handing is over is after 2 years of successful running. So the average energy saving was 35%. Now on furnace number 2, it's a 10 meters long furnace, 70 tons capacity, 1500 kilowatt, 4 pairs were given, and this was energy savings established for 40.31%. That was in 23rd of July. This is all signed things. Then the next furnace again was 120 tons, but length was the same, and the firing number of burners were 5 pairs instead of 4 pairs, as you see above. And again, the savings was around 40%. Now, the 4th number furnace, savings were 31. 5th number furnace, 40 tons, was 36%. But highest was in 120 tons, which was a 12 meters long furnace. The savings achieved were 45% in energy costs. And the last furnace is going to be handed over shortly in November 24. That's the last this thing. If you want to see some pictures on this, following slides have photographs on what was before and what was after.
Yeah.
Can we go to the next slide, please?
Sorry to interrupt you.
No interruption. I love your this thing.
Sorry to interrupt you. Am I audible, sir?
Yes, you are.
Sir, I have one question. In the previous slide, you have said that there is a 45% energy saving. Yeah, the 6th one.
Yeah.
The average energy saving is somewhere around 45%. Does it mean that the fuel consumption has been reduced to half?
Precisely.
So that means whatever the fuel consumption earlier, the specific fuel consumption had been reduced to half.
Precisely. 45% less. Right. Around half. Little less than half.
Okay. So there was no recuperator or what? Without recuperator or with recuperator?
Without recuperators. All the furnaces we are talking is without recuperators.
That means initially with this BHEL 12 meter serial number 6, there was no recuperator and SRB has been installed, and because of that there is a saving of 45%. Is it like that?
Correct. Because, there was no recuperator because no recuperator survives at 1200 degrees centigrade.
That's okay, but recuperator will be there in RHF, without SRB also.
What is SRB? What do you mean by SRB?
This self-regenerating burners.
Oh, regenerating burners, yeah. What's your question now, Dhananjay?
Myself, Bhavesh Patel. My question is that, sir, normally what I have seen these steel plants in the reheating furnace, there are recuperators that are available.
Precisely, there are, but there was no recuperator in BHEL because BHEL was experiencing big time failures of recuperators as their temperatures were very, very high. So the survival rate of recuperators, the average life of recuperators was not more than say 1 year or 1.5 years or 18 months. And the maximum recovery, what you can do through a recuperator, as I mentioned earlier, is 300, 350 or 400 degrees centigrade. And then your pipeline size increases tremendously. All those inefficiencies come in.
Correct,
So
correct.
they were not having recuperators anywhere.
So here, whatever the percentage has been shown that those furnaces were without recuperator, and after installing these burners, this is the achievement. Am I right, sir?
You're right, 100% right.
Any other percentage saving of furnace which already have a recuperator, and then we change these burners and we got some percentage saving, something like that?
No, right now, no, but we are working for such furnaces. But we again, one furnace we have just got the orders because the recuperator was there, and we have still to commission, or means we have yet to supply them the equipment because we are working on the consumptions right now.
Any estimations of saving?
Yeah, we have given that in one of the slides, that from recuperator. See, basically recuperator, if you go from 300 to 1000 degrees centigrade, so your saving will be almost 20% more.
Okay.
If your recuperator is giving you around, say, if you are saving around 15%, normally what we have, because we are the persons who innovated recuperators way back in 78. Earlier recuperators were coming from JP in Germany and Metcon in UK. So they were the largest suppliers to India in 78. PTC Sangli was a company in Pune where we tried Encon recuperators for the first time. So we know about recuperators, what are the shortcomings of recuperators, limitations of recuperators. So recuperators, maximum what you can get out of recuperator is not more than 15% saving.
So
Okay.
one more question here, sir. So if some furnace, we have a furnace where the recuperators are already installed, and if we are changing the burners to this one, do we have to remove that recuperator, or we have to continue with the recuperator?
No need of recuperator.
No need of. And after that, after this, the flue gas temperature will be
around 250. So we can see we plan from 140 to 250 exhaust temperature. Supposingly, but here one thing is these regenerative burners are good after a temperature of around 850 or so.
Yeah, correct. I'm talking about reheating furnace where the temperature is somewhere around 1210.
Okay, for 1210 it's very good.
Yeah.
Very good.
Yeah, please continue, sir. Thank you.
Okay, so we were at 45% saving. So I wanted to show you some pictures of before and after. So if we go to the next slides, we'll have that. Yeah, this is savings. Yeah, this is earlier they had burners like this, standalone burners in their furnace, BHEL before, with a separate airlines and separate everything. And then if we go to the next one, we'll come to know. Next one. Now, here you see those burners, 18 number of burners were replaced by 5 pairs of burners, like 10 burners. So this is what regenerators they came in. So this is before and after. Can you go to the next, please?
Yeah.
So this is all, they are controlled by PLCs, and these are some of the results if you want to see. Yeah.
Hello. Good afternoon. हाँ बोलो.
Go to the next.
नहीं देखो तुम इधर हो ना ओखला की तरफ.
This is what you see is a BHEL panel.
अच्छा.
Now we can show you our panel. BHEL before.
वो जो
BHEL.
वो एग्जीबिशन ग्राउंड को जानते हो?
Sorry, sir. Sorry, once again to interrupt you. Ma'am, ये आप सबको mute कर सकते हो, ma'am. You can mute to all.
मैं भेज दूंगा.
Yeah.
वहाँ पे एग्जीबिशन, हाँ,
भावना से दीजिए आप प्लीज.
एग्जीबिशन है तो वहाँ पे मिलेंगे सुबह. ठीक है, करीब 10:30 बजे वहाँ पे मिलेंगे. हाँ. ठीक है. और तबीयत कैसी है तुम्हारी? बिल्कुल ठीक हो?
मैम या तो आप सिर्फ अजय जी जो बोल रहे हैं उनको भी म्यूट कर सकते हो, उनका जो म्यूजिक है मतलब साउंड का जो सिंबल है ना माइक
Yes,
का,
sir. Yes,
उसको
yes, I
आप
am
क्लिक
doing it.
करेंगे तो म्यूट कर पाएंगे।
Yes, yes, I am doing it.
अच्छा, तो क्या किया? हाँ, अच्छा, तो ध्यान रखो यार, ये बार बार हो रहा है फीवर, तो इसकी जो जड़ है वो पता चलनी चाहिए ना।
Sorry for all that glitch.
No, no, it's okay.
I
It's
don't
okay.
get it. Yeah.
In fact, on my request only you did it. So Bhavna ji, you have not to be sorry.
No,
Yeah, webinars में ऐसा हो जाता है. That's why I think seminars are a little more professional. Anyway, shall we continue, sir?
yes.
Okay. So this is BHEL control panel after, and the earlier one, what I showed you was all the individual burners were done controlled through PID and all those things, but this is all through PLC, 100% PLCs. So there are around 72 operations in a minute which a burner has to go through. So, or maybe more. I'm not going on the numbers. I don't recollect, but everything is done by PLC, right? All the valves opening, all the closing, temperature monitoring, pressure monitoring, everything is done by all PLCs, and these furnaces are maintained at around 2% oxygen. All oxygen controls are also done by them. And pressure, again, we see that it's not more than atmospheric +2. So this is what we do in these furnaces. Can we go to the next slide, Bhavna ji? So this is self-recuperative burners, what we have developed. Now this is where the furnaces are smaller in western region, Pune and those areas, Ahmednagar areas. There are so many furnaces which are standalone furnace with single burners. Here you have a recovery of up to on a temperature application of 1000 degrees. We have established a saving of around 600 recoveries there. 600 degrees is recovered back. So in these burners, this burner in itself is firing also, and it's a recuperator also. So self-recuperative burners. So that's what we have developed. So that we came with this. Next, please. So where you can not let's go to the next, please. There's too much of the theory. So that's the principle how it works. So there's a combustion air, and the combustion air is routed through the body of the burner through the sleeves outside and gets preheated to a temperature of around 540 and up to 600 degrees centigrade. We have been doing it. So this is where you can't do regenerators. You self-recuperative is a very, very good answer. So this is what we have developed for them. And the capex is also much lower in comparison to regenerative burners. Next, please. So yeah, one point. This is what you see is at our test furnaces. Whatever technologies, what you bring in, this is after 2 years of testing any whichever way. So, and I'll like to invite each and every one of you to visit all these R&D centers at our place, or R&D facilities at our place. So you can see this. This is a self-recuperator burner running, it's functioning, everything you can see. And if you see the next slide, if you go to the next slide, Bhavna, we'll see even the regenerative burner also is at our place. So I'm not going for oxy-fuel consumption. Let's go to the next slide, please. Correct. This is the furnaces what you are seeing at BHEL. Now, 96 tons is one single piece. This is one single piece is weighing 96 tons. This is coming out of a furnace of 120 tons. And this is the flame length what you are shown of a self-recuperator, but it can be much shortened also. This is a bigger capacity burner, maybe 300 kilowatts, but for 200, the flame will be much sharper and much bluer. Next, please. We are doing, I think this is not the topic what we are covering. These are other systems what we are making, lead lighting stations, etc. for the mother machineries for, as I mentioned you, for all the SMS sections of Indian steel industry, may it be Jindals or may it be Tatas or may it be SAIL or in neighboring countries like Bangladesh or other Myanmar, Southeast Asia or Central Asia, we're supplying to all of these people. Please next, I think, can we see the other slides? Let me see if there is something interesting to tell them. Yeah, this is interesting. So shall we go one slide back? So this is a recuperative lead lighting station for 50 tons, this thing, but 50 tons and above ladle heaters, we have established a saving of around 25 to 40% on their current consumptions if you put a useful system and you recuperate the gases nicely and seal the top cover of ladles properly. So what you see, this is at JSW, and the savings achieved are around 25 to 40%, depending on, so in vertical it is less, in horizontal it is slightly more. So this is one area what you can always look into that. Next, please.
JSW Bellary, sir. Is it in Karnataka?
Yeah, Karnataka, yeah. JSW, this is, earlier this was plant owned by BMM plant.
Yeah.
This is in fact BMM.
I think he has lost connection. He'll join again.
May I get his mail ID?
Sure, sir. We'll share.
Please.
Type it in the chat box.
Yeah, please.
The other Tandishes, we have done the largest Tandish for the country and for other places also, like Vizag Steel Plant is the largest. Oman JSPL is the largest. There are two big, very large Tandishes that you are going to witness here. So they are all done by us. And that's the most critical heating in any given heating application. There's no, heating as tricky or as challenging as Tandish heating. I think we are stuck, Bhavna. We are not moving ahead.
Yeah.
Yeah. So you can just, these are Tandish heating. Whatever. Can we go through the next ones, please? Just keep on going.
Yes.
These are launder or scrap reheaters also. These are Tandishes. Please keep on going. I think let's have questions now. We have last 10 minutes left. Let's go to the next one. Yeah, this is, I was talking to you, one of the largest. This is oxy fuel burner for a vessel preheater, 7.5 meters vessel preheater. This was earlier Bhushan, now it's Tata something, BSP. Next, please. Just to show you what all we are doing. Or all
Oxy-fuel burner means 100% oxygen, no air. Is it like
no,
that?
no. Yeah, 100%, 100% oxygen. So these are, this can be used as a scrap preheater, but Inductotherm got it from us. I don't know for what purposes. It's a tunnel heat furnace. Now we are trying this for heating continuous casting. Instead of using induction billet heaters, you can always use this tunnel furnaces. This is for billets, but for slab, we are designing a new system for that. Next, please. So we are doing, these are very common recuperators. Since this slide was made for CII, Hyderabad, we had a presentation just now. So we got the national award for most innovative technology. So this presentation was made for there, and I just send the same. Can we go to the next, please? We can have questions now. It's already 50 minutes. Last 10 minutes are there. So these are some burners. What we are doing. We are doing many kind of burners, around 12 or 13 kinds of different burners, mixed fuels, low, like BF gas. Also, we are doing burners with BF gas, oxy-enriched, dual fuel burners, coke oven burners. So anything, if you have some very specific requirements, you can always let us know. We can always develop a burner for that. Next, please. Because this was not the subject today. Let's go to the next, please. Some of our clients, let's go to the next. I think people won't be interested in this. Let's not. Now let's take questions only. If there are any, we can open the forum and have the questions. Next, please. So these are the countries we are in around 39 countries now. Encon has a presence, but not a large one, only in this sector is what I said. So this is what I strongly believe in. Saving environment and energy conservation is the need of the hour. Now this was 10 years back, but still that need of the hour has not finished. So I find we are all morally bound and obligated to do that. So let's all do it together.
Yes.
So thank you very much, sir. Thank you very much.
So these are the contact details, those who wanted to note it.
Please hold on. Please hold on this slide.
Sure, sir. So in the meantime, like if you have any more questions, you may please put it.
Mr. Sir, see, oxy-fuel burners, there are a lot of benefit. If rather than what we know is the just giving air, we can give straight away oxygen. So a lot of benefits are there because nitrogen has a lot of challenges. It produces NOx and all those things, and apart from that, it takes a lot of heat also.
We call it robber.
Robber, correct. So why in the plan in India we have not seen so many? अभी तक इतना popularism क्यों नहीं हो रहा? What are the challenges we are facing if we can go directly straight away oxygen?
20 years back, we came out with there was a company in Chicago. We were partnering with that company. They are still our partners, Jupiter Oxygen Corporation, where my son Puneet was there for almost 2 months to know what this technology was. He learned all this technology, and then we came back to India. And then we tried to, in Musco mein humne try kiya tha for some their soaking pits. So oxygen in itself, earlier because electricity was cheaper, so oxygen was making some sense. Oil was expensive, but now relatively oil has become cheaper. So this is oxygen production in itself is a very expensive proposition. But the places like where you are producing stainless steel and you have a spare oxygen, because you need nitrogen as an atmosphere, and your oxygen is a spare thing with you. So those places you can always go for such technologies. But
Many steel plant, in a steel plant, a lot of oxygen plant is available. Correct.
no, you are right. But they have a specific requirement of oxygen.
Yeah,
That's why
true.
they, have,
True.
they are. So they don't have spare capacities. They
No,
don't
suppose
have,
it's a spare capacity, can we have a economically as well as safety point of view? Will it be viable?
no, we are doing it. Oxygen enrichment is being done by us at so many places.
Oxygen, oxygen
we-
enrichment is possible in almost all the steel plant. Blast furnace, they go oxygen enrichment up to somewhere around 2% to 5%. Barabar. That's okay. I'm not talking about enrichment. I'm talking about straight away giving oxygen rather than the air for the combustion.
Vaishve, I'm giving you that answer again and again. If your oxygen is spare, capacity is available with you, you can always, because you save straight away. See, in our air composition, only 22% is oxygen. Balance is all your volatiles and nitrogen.
Yeah.
And in nitrogen has no role to play in combustion, except for
Absolutely.
warming the heat. We have
Correct.
done all that.
Hmm.
So,
Correct.
so it's not, but as again I'm repeating, the cost of oxygen to use as a combustion medium, wherever you have spare oxygen, it's okay. Wherever you don't have it, it's very expensive.
But safety point of view, is
Oh,
it,
no, we have gas trains developed as safe as possible, man. We are using it. For last 20 years, we're using it.
okay. So safety point of view, there are no challenge. If economically it is viable, yes, we can go for that.
I won't say no challenges, because people here, we Indians are the most casual people. Western India is the most professional, what I found. All over the, if you see the demographics of the country, so the most professional people, what you find is in the Western region. But there also compromises are there. Compromises are there. Even in using gas, natural gas also. I've seen in Dolby plant, some compromise, like we go for always double safety, double that, double all this. But those people, they have all this going on. Compromises going on, left, right, and center. So once they are, natural gas is a very safe fuel. So it's very forgiving fuel. But oxygen is not. With oxygen, you have to be very, very careful. So the answer to your question is you have to be careful, but this is possible.
Possible. Yeah. Okay.
We are doing it. We are doing it. That's what I'm saying.
Thank you.
The AEEWI